Hey, good morning, folks. So, we will be talking about magnetic field due to straight wire in this lecture. Let me write it. Now, a few things to remember. In the last lecture, we spoke about Biot Savart's law. Now, Biot Savart's law basically talks only about incremental length. It talks about dl, which creates dB, a very small magnetic field. In this lecture, we will be talking about a straight wire and how much magnetic field it creates at, let's say, at point P. And point P is in the vicinity. So, let me reiterate. In the earlier lecture, we spoke about Biot Savart's law, and in that Biot Savart's law, we just spoke about incremental distance and the magnetic field it is generating at any point nearby. But in this lecture, we will be talking about what is the collective magnetic field produced by the straight wire, current carrying wire at this point P. Let's get started. Okay, so the first thing, and there are very important points to note here, otherwise it is extremely simple. If you pay attention on those points, I think you're done. Okay, first, let's draw a vertical line from B to this wire. Now, when I say vertical, of course, this angle is 90 degree. Now, let's connect this wire, this wire at that incremental, length to the point P where we have to determine the magnetic field. Okay. Now, connect the two ends of the wire to that point as well, wherein we are determining the magnetic field. Okay. Now, in the Biot Savart's law, we have taken this angle as theta, but just for the ease of comfort, which you will get to know after I am done with this derivation, why I have been using, but for the ease of comfort, I am taking this as 90 minus theta, and when this is 90 minus theta, this is a right angle triangle, so this will be theta. Now, this angle, to this end, let's assume it is theta 1, and the leftover, the lower one is theta 2. Now, a very important point to note is all the angles which we are taking are from the perpendicular distance. So that's the key thing. Second thing, the perpendicular distance from the point where we have to identify the magnetic field to the wire is, we have assumed, as A. Okay, and this length is L. Okay. Let's get started with the derivation now. Before I move on to the derivation portion, only for this triangle, let's see some, let's watch out some trigonometrical ratios. Now, if you see here, you will see that cos theta is equal to A by R, or I can say R is equal to A cos theta. Also, I can say tan theta is equal to L by A, or I can say L is equal to A tan theta. Now with the simple differentiation which we know a bit, we will differentiate both sides. dl is equal to a sec square theta d theta. Okay, now leave it aside. Now we are preparing something, and this is one of the ingredients which we would be putting there. Now I am going back to the Biot Savart's law, which we have already discussed in the earlier lecture. As per the Biot Savart's law, we know dB is equal to mu naught 4 pi I dl by r square sine, remember it was sine of this angle, but in this derivation I have assumed this as 90 minus theta rather than theta, which was assumed in the earlier lecture. So I will put whatever we have assumed here. So this is sine 90 minus theta. Okay, now what I will do is, after putting this, remember this is only for this incremental length. So right now I will think in the scenario we are in. In this scenario, we will integrate both sides from, let's say, theta 1. Let's take this side as positive. Let's take this side as positive and this side as negative. So I will say that I am integrating it from theta 1 plus theta 1 to minus theta 2, because this is the standard from which we are trying. What is the standard? The perpendicular. Okay, so I am integrating both sides. So if I integrate both sides, it becomes B is equal to mu naught 4 pi I dl by r square, and this becomes cos theta, as you know from trigonometry. Here I will write plus theta 1 to minus theta 2. I hope it is clear. Okay, now whatever we have we have prepared here, these are the ingredients of this, so I will be putting it there. Okay. Now what I will do is, I will take whatever is common out of it. So if I put it this way, then this becomes theta 1 to theta 2 mu naught 4 pi, correct? In place of I, let me put it I itself, because I is a constant. The current is constant. So this is the current, by the way, which is a constant current flowing, so it is constant. So the good thing is this will come out, or let me put it this way, let me help ease it out, and let me start putting it all the constant items outside. So it becomes mu naught 4 pi I, and then I will say theta 1 minus theta 2, dl is inside, r square is here, and cos theta is here. Okay, very good. Now I go back again here, r is equal to a cos theta, and we have r square. So what I have done is, I will do it mu naught 4 pi I theta 1 minus theta 2, in place of dl, let it be dl, r square. So what is r? A cos theta. So this becomes a square cos square theta, correct, into cos theta. Okay, so now if I substitute these values, we will see cos theta cancels, and this becomes a square cos theta. You know, a was already there. So if I work it out, if I write it this way, it becomes mu naught by 4 pi theta 1 by minus theta 2. Okay, and it becomes cos theta d theta, right? Now one of the a, you know, comes here, a. Okay, okay, so this is what we have. One of the a gets cancelled because a cos ka theta, yes, correct. Yeah, okay. So if I further solve it, this becomes mu naught by 4 pi I by a, and this becomes cos theta. What is the, you know, if I take integration of cos theta, what is what would be that? It would be sine theta, and it is, you know, from so it will be what? It will be theta 1 to minus theta 2. Now if I further go, this becomes mu naught 4 pi I by a, and this becomes you know, sine theta 1, minus minus becomes plus, it is sine theta 2. Okay, so this is the magnetic field, you know, because of this finite, you know, current carrying conductor, which is a straight wire. Okay, now what we will do is we will do some practical examples of this so that we can get a very good purview of and understanding of the same. Okay, so with this I am taking a pause. We will continue you know, in the next lecture. Thank you.